Hi everyone. In this video I thought I would spend a little bit of time demonstrating how to use the AMOS drawing program in order to draw out various types of statistical models that you can run using the program. So AMOS is a structural equation modeling program, and it incorporates a graphical user interface that's really easy to use when it comes to drawing out various structural equation models. It does have the capacity to use syntax. However, most folks, when they're using AMOS, they will just rely on the graphical interface. So this is what it looks like. And so what I'll do is I'm going to walk you through a few models, just basically drawing them out and running them, just so you can kind of get a feel for how to use the interface. Also, the data that we're going to be working from is this data set right here, and I'll include a link to it underneath the video description so that you can download it and you can follow along with the drawings and the analyses that I perform. So with the drawing interface, what we're going to do is essentially draw out some models in this white space here, and I typically like to expand this out a little bit to have a little more room. So I'm going to go over here to View, and you'll see that we have this little option here for interface properties. So I'm going to click on it, and under paper size I'm going to select legal to kind of give me some more space to work within. Now when you are working in SEM, we typically represent two types of variables. We have variables that are manifest or observed in your data set, and then there are those that are latent or hidden. Basically, they're not directly observed, and typically they're implied from the data. So in our data set right here, we've got a number of different variables. We're going to rely for the first demonstration on this performance goal variable and this achievement variable, and so both of these are essentially sum scores from a survey. So what we'll do is I want to draw out those two variables. So to do this, I'm going to use this little rectangle over here that says draw observed variables. So we're going to use that rectangle to represent those two variables. So I'm going to click that button right there, and you'll see that it stays highlighted. And when I go over to the drawing space right here, I can just click and then drag, and you can see that I can draw out my little rectangle right there. And I can do the same thing for the second variable as well. So I can just click and drag, and that variable, that box appears as well. So now what I want to do is to let's just say I want to go ahead and bring the data into SPSS because I need to bring the data in, and then I need to assign the variable names to these boxes. So what I'm going to do is I'll click off my little rectangle there and click this button right here for select data files, and I'll click on file name in order to access the data file. Okay, so this is the data file that we're going to be working with. Like I said, you can access this by following the link that's provided underneath the video description. So we'll click on open, and so now you can see that file name shows up, and I'll click on OK right there. And we'll go back in here, and so now I'm going to name the two variables. So I'm going to click this little button right here that says list variables in data set, and I'll click on performance goals and move it up to this box, and then I'll click on achieve and move it to this box right here. Next, what I'll do is I will select this double-headed arrow here, and this is going to draw a covariance between these two variables. So I'm going to click that button right there, and then when I highlight this one in red, I can click and drag over here to this box, so you can see it turns green, and then when I release it turns red, and so that's basically a covariance that is drawn between my performance goal variable and the achieve goal variable, or the achievement variable. So now let's say that I just want to run the analysis. I want to essentially generate some estimates. I want to generate the covariance between those two variables as well as the variances for those variables. Well, it's actually pretty easy to do, and the first thing I'm going to do too is go under analysis properties, because something else I need to mention to you is that the default estimation approach in AMOS is maximum likelihood. So most of the time when people are running structural equation models in AMOS, they have maximum likelihood selected. This button right here for estimate means and intercepts is typically selected in those cases where you have missing data that's evident in your data set. There are other reasons, but that's one of the main reasons that somebody would click on that. For our data set, we don't have any missing data, so I'm just going to leave this unclicked. And when I click on, you'll see that at the top there are various options available. These tabs give you different possibilities when you're running your analyses. I'll go ahead and select output, and when I select standardized estimates right there, then what this is going to do is it's going to generate the correlation between my performance goal variable and the achieve variable. So essentially, when performance goal and the achievement variables are in unstandardized form, then what's going to happen is that the relationship that's reflected by this double-headed arrow is going to appear as a covariance. But by selecting standardized estimates, I can also obtain the correlation between those two variables. So I'm going to select out of here, and then when I click on this calculate estimates button, I'm going to get prompted to save the file. So I'm going to click on that, and this box has come up. You can already see I've been saving things, but I'll go ahead and I'll just save over the demo file that I have in there, and we'll click on yes. And so now we've run our analysis. And so at this point, I can obtain my estimates by clicking this little toggle right here. And you can see that under standardized estimates, this is the correlation between the two variables. So it's a minus 0.29. So there's a negative relationship between performance goals and achievement. If I want the unstandardized estimates, then in this case, this is the covariance between those two variables. And we have the variance for performance goals and the variance for achievement that are given above each of those boxes. Now, typically, when people run structural equation models, they want to evaluate the overall fit of the model, and that's generally done by using various fit statistics. So it's kind of pointless in this particular case to try to evaluate the overall fit of the model, because this model is actually a just identified model, and degrees of freedom for this model are 0. But just to show you where to go, you would click under this box right here for view text, and if we go to model fit, you can see that we have the various fit statistics that are given. As I said before, though, this model is actually just identified model, and so it's pointless to try to evaluate the overall fit of the model, because the fit indices that are given right here are generally going to say, hey, it's a perfect fitting model, and so again, that becomes rather pointless. So at any rate, this is essentially just specifying the covariance between two variables. Now let's try to run an analysis where we have where we're specifying a multiple regression model. So I could start up a new AMOS file, or if I wanted to, I could just save over this after drawing out a new model. So I'm actually going to go ahead and do that. So I'm going to click this toggle and take us back right here. And if I use this little X right here, this is to erase objects. So I'm going to press that button right there, and so anything that I move the X over and click, it's going to get rid of it. So now I'm going to unclick, and now what I want to do is I'm going to redraw my model. So I'm going to click up here at the rectangle again, and I'm going to draw out a box right here. And again, I could draw these out continuously if I wanted to, but I like to have things nice and proportionate. So what I can do in this case is I can deselect, deselect that option right there, and I can go over here to this little photocopier and click on it, and when I go over to the object, you'll see it highlights in red, and you can see a little photocopier. If I click and drag, you can see that now the box is exactly the same dimensions as the original one. So you can see I've drawn out 3 different boxes, and here's my outcome variable right here. So it's really that simple. So I'm going to click off of my little photocopier right here, and basically, because if I go back right here, because we're still just using the same data set right here instead of starting up a new file. If we had started up a new file, we would have to re-import. But in this case, the data is already still waiting for us. So I'm going to click under this list variables in dataset box, and I'm going to create a model. So what I'll do is I'm going to move my achievement variable over here to this box. I'm going to move performance goals to this first box on the left, mastery goals, and then I'm going to move this this interest variable over to the left as well. So to draw out the paths from each of these variables to the achievement variable, I'm going to select a single-headed arrow. I'm going to select that icon and then draw them out. So it's just really this easy. So there are those three arrows right there. And then typically we want our predictor variables in our regression model. We want them to be correlated. So now I'm going to deselect that single-headed arrow and select the double-headed arrows. And so now I can just draw out the correlations between the different variables. Now I will mention that if you kind of adopt sort of a different orientation, this is what you get. So in this case, I'm just drawing from the bottom to the top boxes right there. All right, so we're just about done with drawing out the regression model, but there is one other feature, one other component that we need, and that is an error term associated with it. So in other words, we need to capture the prediction error in achievement, essentially reflecting that variation in achievement that's not accounted for by the predictors. So I'm going to deselect this double-headed arrow and select this icon right here for add a unique variable to an existing variable. So I'm going to click on it and then go over above this box right here and highlight it and click this button. And so now you can see I get a circle with an arrow drawn from it, and there's a little 1 in there. So I'm going to, in this case, I'm going to deselect that object, and basically that the circle or ovals that you see within any kind of SEM model refers to either an error term or a latent variable. So typically you'll oftentimes see latent variables like in a factor analytic model being represented with ovals, and then error terms more of like just a straight on circle. But basically anything like a circle or an oval indicates that that variable is unmeasured or is not measured directly. So what I'm going to do in this case is I'm going to right click on this object, and you'll see this little option come up, object properties. I'm going to click on it, and under variable name I'm going to type a D in there. Now that's just me being kind of arbitrary, but in common multiple regression analysis, we tend to refer to the residuals or prediction error, in that sense. In SEM kind of terminology, we refer to prediction error in these kind of circumstances as being a disturbance. So I'm just using a D for disturbance. Also, I want to point out sort of a few other differences in how we talk about the variables. In a standard regression model, in this case we would have performance goals, mastery goals, and interest serving as independent variables or predictors, and the achievement variable would represent a dependent variable or a criterion variable. In SEM notation or SEM terminology, we refer to variables as being exogenous or endogenous. So exogenous variables are those that don't have a disturbance term associated with them, and they are unpredicted in the model. So performance goals, mastery goals, and interest in this model, we could refer to them as exogenous variables, and the achievement variable right here as an endogenous variable because we have an error term associated with it. Nevertheless, with the exogenous variables, we typically allow those variables to correlate. So that's why we still have our double-headed arrows to the left of those boxes. Okay, so now we're going to run this analysis, kind of going back to analysis properties. In this case, I still have my standardized estimates that's selected. I'm also going to select squared multiple correlations. And by selecting that, I'm going to get the R-square value that's associated with our endogenous variable achievement. By selecting standardized estimates, what I'm going to do is under the standardized solution, I'm going to get the path coefficients there are going to effectively be the beta weights. So typically, like in regression analysis, when you come up against standardized regression weights or beta weights, those are the values that we can generate from that. So at any rate, what I'll go ahead and do is I'm going to click on calculate estimates right here. And when I click this little toggle right here, you can see under the unstandardized estimates, the double-headed arrows, the values associated with these are the covariances among the variables. The values above each of these boxes are the variances of those variables. This is the variance of the disturbance term. And then you can see that these would all be the unstandardized regression weights, or unstandardized path coefficients, if you will. When I click on standardized estimates, now you can see that I get above the achieve box, my endogenous variable, the 0.40, that is actually the R-square value, reflecting the proportion of variation in achievement accounted for by the predictors. You can also see that we have our standardized path coefficients that are given right here, and then the double-headed arrows are giving us the correlations among our exogenous variables. Once again, if I go under the text box right here, go to model fit, you'll see that the degrees of freedom for this chi-square test right here is still 0. And so this, again, is consistent with the just identified model. So basically the last two models, the covariance model that we tested and also this model, because they were both just identified, we can't really use any of the fit statistics to evaluate the overall model fit, or the conventional fit statistics that we use. But nevertheless, we can still evaluate the components of the model by going to the estimates box right here. And you can see that the regression weights right here, these are the unstandardized regression weights or path coefficients. So you can see that the path from interest to achieve is positive. There's our p-value right there. It's statistically significant. The path from mastery to achieve is positive and statistically significant. And then the path from performance goals to achieve is actually negative and statistically significant. And then the standardized regression weights, these are the same ones that we saw before in the diagram. So all of these estimates we saw before when we clicked back and forth between the unstandardized and standardized solutions. The covariance box right here, these are the covariances among the exogenous variables as well as significance tests. So all three of the covariances were statistically significant. We have the correlations among the exogenous variables right here. And then we have our variances. So the variances for our exogenous variables for interest is 3.126, for mastery 1.944. For performance goals, it's 383.165. And then we have a variance for the disturbance, which is 0.96. And then finally, we have the squared multiple correlations associated with the achievement variable, and that's the 0.404. So again, the predictors accounted for approximately 40.4% of the variation in the achievement variable. Okay, so let's expand this a little bit more and into a larger path model. So what I'm going to do now is show you another tool, which is this little moving truck right here. So if I click on it and then highlight a part of the drawing, I can move things around in the drawing. So you can see right here I'm moving the achieve variable over. There I'm moving the disturbance term over right there. If I want to move the arrows, I can click on it and move it, something like that. So that's a really handy little tool to have available to you. So now what I'm going to do is I'm going to use my little photocopier right here and select achieve, and I'm going to move this out right here. So and then from there I'm going to draw in a path from this box right here to this achieve box out here. So we're not going to have achieve predicting achieve. What I'm going to do is I'm going to put another variable in between my exogenous variables and the achieve variable. So I'm going to go and select under the variables in the list. I'm going to select, let's see which one of these I want to select. I'm going to select this anxiety variable right here. So I'm going to click on it and drag it up. And so now you can see that variable is appearing. And then I'm also going to have to draw in another disturbance term. So in this case, the exogenous variables are performance goals, mastery goals, and interest, whereas the endogenous variables are going to be anxiety and achieve. So I'm going to click on this button right here to add a unique variable, and there it is. And so now I need to name this particular variable. So in this case, though, I can't have the same name as what I had before. So I'm going to right click over this object, go to Object Properties, and I'm going to type in just a D2 right there, and I'm going to click back over here and just call this a D1. And so now you can see that I have both of my disturbance terms that are drawn. So at this point, let's just go ahead and run this particular model. So I'm going to click on Calculate Estimates right here, and you can see that we've run our model. And when I click this button right here, you can see that we have our unstandardized estimates that are given as well as the standardized estimates. Once again, in the unstandardized solution, we have the covariances among the exogenous variables, the variances of the exogenous variables that are given, the unstandardized path coefficients or unstandardized regression weights that are given in both parts of this model. And then we have the variances of each of the disturbance terms that are given. Now, at this point, you'll see right here the chi-square value is not 0 and degrees of freedom is not 0. And so this is where we have a degrees of freedom that's greater than 0, we have what's called an over-identified model. And you might think that that's bad, but that's actually a good thing, because with an over-identified model, now we can use the global fit statistics to evaluate the overall fit of the model, in addition to looking at each of the tests related to each of the parameters within the model. So what I'm going to do is click on this button right here and look at our model fit. And so now you can see that we have right here, this is the chi-square goodness of fit test. Generally speaking, if this test is significant, that's actually an indicator of poor fit. The chi-square test is a test of exact fit of our model to the data. So you can see it's statistically significant, which would be an indication that our model is not fitting the data. Now, keep in mind that the chi-square goodness of fit test is affected by sample size, and given that this is a large sample procedure typically with SEM, we oftentimes don't rely solely on that information, but we look at various fit statistics. So other indices that we might consult include the GFI and AGFI. Generally, values that are above 0.90 or above would be considered indicative of at least an acceptable fitting model, if not good. The same would go for the TLI and the CFI right here, and you can see, really with the GFI, AGFI, the TLI, and CFI, all of those are indicating really just pretty abysmal fit. As we scroll down, you can see that we also have the RMSEA. This is another index that's oftentimes consulted. And a value that is 0.05 or below would be considered as indicating that the model is a close fit to the data. Up to about 0.08 would be considered acceptable. So you can see right here, this is indicating a really awful fit of the model to the data. So when we click on estimates right here, we can look at each of our path coefficients. So you can see interest to anxiety, the unstandardized path coefficient is somewhat positive but not significant. You can see that the coefficient from mastery to anxiety is negative and statistically significant. The coefficient for the effect of performance goals on anxiety is not significant. The effect of anxiety on achievement is negative and statistically significant. Again, we have our standardized coefficients that are given right here, and as we scroll down, we have our covariances among the exogenous variables that are given. The correlations among those exogenous variables are given in this little section right here. The variances of our exogenous variables are given right here, as well as the variances of the disturbance terms, and then here we have the R-square values associated with the anxiety and achieve variables. So overall, as we were looking at our fit statistics and so forth, this was a pretty poor fitting model to the data. I'll show you another model right here. Let's say I want to add a path from the interest variable to achievement and from performance goals to achievement. I'll add those in there and we'll rerun the model. Basically, the chi-square is better than it was before, but we'll go ahead and click on our output file right here, and so you can see the model fit. Again, the chi-square test is significant. As we're looking at the GFI, it's definitely better than it was before. The AGFI and TLI are just extremely poor. CFI would be sort of minimally acceptable. if we were just looking at that alone. The RMSEA is well above 0.08, and so that's really just indicating very poor fit. And I do want to mention that when we're evaluating the overall fit of a model in SEM, we don't typically rely on a single goodness of fit index. Typically what we do is we consult a set of them because each of them kind of provides a different lens for evaluating the fit of a model. But when you have a situation like this where most of them are indicating a very poor fit, then that's what I would trust the case to be. All right, so other things that I wanted to point out it was in terms of the options that are available in AMOS. If we select all objects, if I click on this little hand right here, this open hand, you'll see it all turns blue. And if I wanted to move things around, I can click on the little moving truck right here, and I can just move the entire figure around to wherever I want. So that's a nice option. So if I want to get rid of the select all objects, I'll just click deselect all objects. If I want to select one object at a time for some reason, I can click on this little hand with the single finger right there, and so I can click on this one right here and this one right here, and so all three of those turn blue. And let's just say I wanted to move that as a group instead of moving one object at a time, which is what I would have had to have done if I was using this moving truck by itself. So if I use the moving truck in relation to what I've selected, now these three objects all move together. So that's a really nice thing as well. So I'm going to deselect this, and we'll kind of deselect our little moving truck right there. Another thing to kind of point out is if I go back to my parameter estimates for this particular model, there's a little object right here. It says move parameter value. So sometimes you can see, like right here, this path coefficient is kind of hidden behind this other object. So I can use this little icon right here for move parameter value. So I can click on it and then go back to the path diagram and click on it, and then I can move that coefficient around. So it's a pretty handy little tool to have. So I'll go ahead and click off that box, that icon right there. And I guess the last thing I want to show you right now is dealing with missing data. I've already kind of highlighted that if you happen to have missing data when you are running your analysis, then one main option that you have is to click this button for estimate means and intercepts. If you have missing data and you don't click that, then what's going to happen is you're going to get an error message. So just kind of keep that in mind. Just to show you what I mean by that is I'll kind of go back to my data file right here, and I'll open up the original data and save it after kind of deleting a couple of cases. Okay, so once I press the View Data button, then my SPSS file opens up. And let's just get rid of a couple of data points. I'm just going to pick a few at random right here, and I'll go ahead and save this also as we'll just call this MD for missing data. So I'll just kind of do that right there. So MD for missing data. And so now what I'm going to do is I'm going to import that data file in and run it without that selection. So I'll go under file name right here, and I'll select this one with MD and click on open, and then OK right here. And again, we don't have estimate means and intercept selected. So now when I press this button for calculate estimates, I get this error message, and it says, in order to analyze data with missing observations, you must explicitly estimate means and intercepts. So I'm going to click on that right there, and now when I run the analysis, it works out fine. Basically what it's using is a full information maximum likelihood approach to the model estimation. So that it's an approach to dealing with the problem of missing data. Another couple of things, actually, now that I think about it, or another thing that I want to mention too, is this, when we are looking at these paths from the latent variable to are these error terms to the boxes that you see right here, you'll notice that both of those paths are fixed to 1. And the reason why is because whenever you're running SEM and you have variables that are not directly measured, you have to set the measurement scale of those variables. And so to do that, one option is to essentially set the variance or fix the variance to 1, or we might fix the a path coefficient, if you will, to 1. And so that's what the default is with respect to these two error terms. So just to show you what would happen if I got rid of this, let's just go to Object Properties and click on it. If I go to parameters and I get rid of that coefficient right there and I try to run the model, then you'll see that nothing comes out. The model is what is called unidentified. So, and basically we can't estimate the parameters in the model. So if I go into the output right here, if I go under the nodes for the model right here, you'll see that it says the model is probably unidentified. In order to achieve identifiability, it will probably be necessary to impose one additional constraint. So that constraint in this case is the need to have that path coefficient fixed to 1. So if I right click and click on Object Properties and go down to Regression Weight right here, if I reinstall that or reinsert that and click on Calculate Estimates, now you can see that it comes up fine. So the model is estimated and it's not going to be unidentified. Okay, also just really quickly, if I right click on performance goals, these different variables go under text. You'll see that the variable names are given after we had imported the variables. If I wanted a different label, now the variable name is what is appearing in the SPSS data file, but let's say I wanted to change the name that's showing up in the path diagram. I can do that by going under variable label. So let's just say I wanted to type this out in all caps. I could type in PERFGOAL, and let's just say I wanted performance goals 1 for whatever reason. In this case, you can see that now that label appears, even though when the analysis is run, AMOS is pulling the variable as it was originally named from the SPSS data file. So that's a really kind of handy thing. Sometimes the variable names in a data set are not exactly what you would ideally have in your path diagram, and so you can make those changes, and when you run the analysis, it's not going to affect anything in terms of the output. Okay, so that pretty well concludes this introduction to using AMOS, and I appreciate you watching.